this video, we do part 2 of the exercise cost of capital, the three tables for levering. Good. So if we continue with question 4 here, it then says, assume instead that ABC is financed with debt such that debt over value is 74%, and that the debt is rebalanced continuously. So rebalanced continuously. What is the value of ABC? Value of ABC. Good. So basically, we have these three tables, right? And there, you in the lecture notes, you're both given how you can calculate the return, right? So the R basically, and also how you can calculate the beta. But I basically like to and also return on assets and so on. There's a lot of stuff that you can remember. So at the end of this exercise, I'll basically go through some of the reasoning and some of these formulas, right? But here, I just want to introduce you to remembering as few formulas as possible for solving this particular question. So in this one, we just have one formula that we need to use for this one. Because remember that in Modigliani and Miller, so this is really not something particular to these three tables, they present us with the formula that says that RE is equal to RA plus RA minus RF, or return on debt, but in this case is RF, but let's maybe actually just make it general. Let's do debt times DRE. Okay. So that's one formula that we get here, and we can actually use this, right? Because we're given in the exercise that debt over value is 74%. This means, by the formula that we've been through a few times, that debt over equity is then 2.85. Good. So with all of this, then we can actually calculate that our return on equity, we have all numbers that we need. We know that the return on assets is 8%, right? And we can just plot this in, and we can say 8% minus 2% times 2.85, right? So just remember that in the exercise, we're actually told that debt is you can think of debt as being risk-free, right? And we've also calculated earlier that the return on assets is 8%. Good. So we jump down here, and then we find that given this, then the return on equity is 25.08%. Good. We then need to price this company, right? So we need to use WACC. And WACC is basically R star, which is one of the things that are presented in this slides, right? That's really it. Like WACC is a weighted average cost of capital, is a true discount rate. So you can think of those two as being the same, right? So think this way. R star is what is presented on your slides. And we know that weighted average cost of capital is a weighted average of your different claimants on your cash flows, right? So basically the formula is this plus RE times ERV. In a world with tax, you don't have tax here. Good. So we do that, and we say that the return on debt is 2%. And we know that we have 74% debt, right? 74%. And we know that we have a tax rate of 35%, but let's just write T here. And then we use this number, 25%, 0.08. And how much equity we have is basically 1 minus 74%, right? It must be the opposite, basically, of this. If you run the numbers, you find that WACC is then equal to 7.48%, or our R star, not 2, but just one line here. So that gives us, if we don't want to price, a present value of 43077. I'm just rounding up here, right? But this is basically the big long number from previous video, this number here. 1 minus t over 0.0748, right? Basically this number. This gives us a value of 3742,31 million, right? And I just want to write here in these exercises, note, which is also what we assume throughout, is that debt is assumed to be risk-free. So this is basically the answer. Right. So this is the case if it was rebalanced continuously. Now let's move to question 5. So you have the same debt over value, so you still have debt over value of 74%, but now debt is rebalanced yearly, right? And what is now the value? So let's start with some formulas again. Formula. We have, in this case, that RE, now I'm just using lowercase, is equal to RA plus bracket RA minus RF or RD. It's assumed to be risk-free, so it's the same. 1 plus tax times RA minus RF. 1 plus RF here. And let's actually just make this bracket go through like this. Good, I close the first bracket, I close the other bracket, times DOE. So now we can plug in our numbers into this horrible looking formula. And we can say that return on equity is equal to 8% plus 8% minus 2%. 1 plus 35% times 8% minus 2%, 1 plus 2%. And then we know from before that this is 2.85. This gives us the return on equity is now 24.96%. This gives us a WACC. If we do the weighted average cost of capital again, so basically RD times 1 minus tax times DRV, you just plug in the numbers here. I'm not going to write all the numbers again. Right? Then with these new numbers, so basically using this in the place of return on equity, I get that the cost of capital now is 7.45%. And therefore, I can now calculate the present value as saying, I know this is not going to change, right? And I know from earlier that this was 280. I think I did that somewhere up here, right? There. So let's just write 280 over 7.45% gives me 3757.62 million, right? So basically you see that this number is slightly larger than this number, right? This one is slightly larger. Good. And then my question to you, so I mean now we've basically done this exercise, right? My question to you is, what is the intuition between these three values? So maybe just think about this just for a second. So when you do this, so you can basically say, so now let me try to draw this up in a good way. You basically have the case where debt is fixed, right? That's one case. You have a case where debt is rebalanced continuously. And then you should think of debt rebalanced yearly as sort of a middle way, right? But why is it actually that these three ways are interesting at all? In this case, when debt is fixed, right, then your tax shields must be risk-free. Tax shields are risk-free. Important. Because basically, if you look at a firm, right, and think of a firm as being looking something like this. You have debt, right? And then you have additional cash flows, right? That goes to equity holders. Even though this grows over time, your debt stays flat, right? So that means, right? So even though this cash flow to equity holders goes up over time, means that tax shields are constant, right? They're basically independent of your firm performance. So therefore, they are risk-free, which is also what we saw in one of the earlier sub-questions to this exercise, is that we basically discounted it with the risk-free one, right? Up here, we saw this formula, present value of tax shield, and we saw this thing here, right? In the case where debt is rebalanced continuously, and this is the interesting thing, I think, you actually have that the size of tax shields follow assets, right? Because basically what it says is that if you have this example again, you have some debt, right? And then you have basically your equity holders here. But then if firm performance goes up, you basically have the debt proportion. This is not really a nice looking line, but basically the proportion of debt goes up. So that means that tax shields move with assets, which basically means that it or they, the tax shields, it inherits risk of assets, which might seem counterintuitive, right? But it's the way it is basically. Even though your debt might have, let's say that the debt itself is risk-free, then the size of your tax shield will go up or even down, right? If your firm performance went down. So say that your firm performance actually, maybe let's do red for illustration purposes, went down. Your tax shields would also go down because your debt would diminish over time because you would be rebalancing continuously. So that means that the size of tax shields follow assets. You discount with return on assets. When you discount it with return of assets, value goes down, right? Because return on assets, the cost of capital as assets, is higher than return on risk-free. Okay, and I'll write some of this in sort of plain English on the virtual whiteboard here in a second. But then I said, think of this as a middle way. And the reason why you should think of this as a middle way is that when you rebalance it yearly, then your first tax shield is risk-free, right? Means that we discount with RF because you're not going to rebalance the next year for sure. That's what it says, right? By definition, you're not going to rebalance the next year, so I know exactly what kind of tax shield I get after, in 1 year from now. But after that, then you use RA. After that, RA as it follows assets, right? So basically, in that case, down here, now I'm using a black, I hope that's okay. If your firm performance goes up, you basically, you follow firm performance, but think of it as saying that the next year is fixed, and then you sort of, you adjust yearly, like this, right? Your debt and sort of So this one right here is fixed, meaning that you discounted RF. These here follow assets, meaning that you discounted RA. So that's why these three methods at all are actually interesting when debt is fixed, when debt is rebalanced yearly, and when debt is continuous. So you might actually, look at these very horrible formulas and wonder why do we even need these and so on. And what they do, and we'll have them in a whiteboard at a second, but what this horrible looking formula actually do is that it takes account of exactly these facts here, whether something should be discounted with the fixed rate, so the return on the fixed asset, risk-free, sorry, or on return on the assets, RA. Good. So let's actually write some text here. So note, a learning here. And it's nice to learn, so let's add a smiley, is that when debt is constant, and this is good both to know when you do exercises, obviously, but also if there was a memo on something like this where you can maybe brag a bit by actually saying that you understand these. Tax shields are discounted with RF when you continuously relever, right? So continuously update your debt level in the firm, right? That's the tax shields, are discounted with RA. Okay, because the size of tax shields follow your assets. Right? And this is really key, and I don't think that's really conveyed very nicely in most books and notes and so on. Right, and so basically that's one scenario, that's the other one, and then you have the third one, when you rebalance yearly. This is a middle way where the first tax shield is discounted with RF, the rest with RA. Okay, and if this is true, right, then we should expect that the one where you rebalanced yearly, the firm value is slightly higher than where you rebalance continuously, because you have 1 year where you discount just a little bit less than RA. And let's see in our numbers if that is true. This right here is 3742. This right here is 3757. And the last number that we calculated is exactly where we rebalanced only yearly. So that hypothesis was indeed true. Good. I'll pause the video here and then I'll come back and then we'll actually just do some tables and some things to remember for the exams. But that is not related to this particular question as such, because we have now actually answered question 5.